Hello everybody. So today we're going to talk about functions, and we're also going to talk about fractional parts of numbers. Now the fractional parts of the numbers, we've talked about that at length, so I'll just quickly review that. I'm not going to do any examples. If you look at your book, problem set 28, example 28.1, 2, and 3, there are 3 really good examples. Just remember that when you're writing fractional parts of number sentences, you have to pay attention to whether it wants you to write the fractional part as a decimal, a number, or a fraction. And just recall that you're translating those sentences into actual equations. So in the first one, when it says 3/4 of what number is 69, so you're going to write 3/4 times Wn equals 69. And then you just use the inverse operations to solve that. If you go to 28.2, it says what fraction of 40 is 24. So WF of 40 is 24. So WF times 40 is 24. Remember that you're going to leave it as a fraction in this case because it starts with a fraction. And then on the third one, 2.5 of 240 is what number? So 2.5 times 240 is what number? What number implies what number? So you can leave it as a number, leave it as a fraction, leave it as a decimal. It's really up to you. All of those are numbers, so it really does not matter. So I'll go ahead and leave that in your capable hands, trusting that you know how to do that, and we'll focus on what a function is. Now, you guys have been doing graphing where you have an equation of a line such as y equals 3x plus 4, and then you're supposed to find values for x and y where I always tell you to pick 1, 0, and -1, for example. So this is actually a sort of function. It's for every input of x, there's exactly one value for y. That's a relationship. So functions are relationships of inputs and outputs. So we're going to study those a little bit more in this lesson. Now, a function is pretty much the same thing as an evaluation. The only difference is functions are written in a certain format. They're usually written with f of x equals something, but you can use any letter. It doesn't have to be f. It could be g of x, s of x, where the letter is going to stand for what you're looking for. So for example, if you're wanting to find profit, then your function would be titled p of f, for example. So really, it's just a way of notating the relationship of the input, the information you're giving in order to find a specific result that you're trying to obtain. So I'm going to go on example number 4, and it's already been written for you, and then I'll be doing example 5. These are, if you notice, x, parentheses x squared minus 3x, if x equals 2, is exactly the same thing as example 5 in equational format, x squared minus 3x, find f of 2. The only difference is the if right here tells you to evaluate, where over here it's saying if the function of x is x of x squared minus 3x, so what it's saying is if this is your function, then find f of 2. That's the only difference. So let's start here. We're going to take x and we're going to evaluate by substituting 2. Now recall that your rules for evaluation tell us whenever you multiply or have exponents, you have to put parentheses in order to protect the PEMDAS rules. So here, because this is an exponent and this is multiplication, we're going to put a parentheses. Over here, we're going to put 2. So everywhere I see x, I'm going to evaluate by substituting for a 2. I'm going to put 2 squared minus 3 times 2, and there we go. It is really important that you remember to do the parentheses so that when you have negative evaluations, you are protecting those negatives and evaluating correctly. Now, following the rules of PEMDAS, I'm going to do the exponents first. So this is 4 that I'm going to multiply times 6. This is all in parentheses, so the next step would be to do subtraction, so that would be -2. And then this is still in parentheses because that's being multiplied. So we see that the answer is 4. -4. Now notice I didn't say x equals -4 because I'm not solving for x, I'm evaluating for x, so the answer simply is -4. Okay, so moving along to the next example, let's now look at the function and we'll see how it's going to come up with the same answer. In this case, we're saying if the function of x equals x parentheses x squared minus 3x, then find f of 2. So we're going to take this and we're going to evaluate it or substitute it here. So we're going to leave the f, but in parentheses, rather than putting an x, I'm going to put a 2. Now this is telling me what my function is. F of 2 equals, wherever there's an x, I'm going to put a 2, 2 squared minus 3, 2 squared. Times 2. So now you can see that this is going to be the exact same thing. The only difference is the way we notate it. This is what we call functional notation. Function of 2 equals 2 parentheses 2 squared minus 3 squared. We will say 2, 4 minus 6, 2 minus 2. And then this time f of 2 equals negative 4. So the only difference is the way that I write my solution. The function of 2, when you input the function of 2, when you input the 2 everywhere, is going to be negative 4. So this would be the proper way to write your function. That's really the only difference between evaluation and function. Again, remember that don't get tripped up on the letter f. Just yes, f does mean function, but it could be the function of g of x, the function of p of x, or whatever it is that the book is asking, and simply meaning the variable in parentheses is going to have a replacement value everywhere in the expression where that particular letter is. Okay, guys, if you have questions, let me know.